Good morning all. So in today's class we will begin the course ordinary differential equation. So we will move on to our modules. So our course is 16P1 MA TT04. So that is ordinary differential equations. So we will be having a total of 4 modules, and your textbook 1 is, there are 2 textbooks actually. So textbook 1 is differential equations by George F. Simmons, and textbook 2 is differential equations by Shepley-Elros. So the e-books for both are available, and in case if you are not able to find that, so I can send you an e-book of that or the respective modules. So we will be having a total of 4 modules. So in first module we will be mainly looking at the system of linear differential equations. So you have seen how to solve for linear differential equations, higher order linear differential equations in your undergraduate course. So in this course you will learn how to solve for a system of linear differential equations, and in the second module we will be mainly looking at power series solutions, and in the third module we will be looking at the Sturm-Liouville problems, and in the fourth module we will be introducing the Laplace transforms. So those are the main overall contents of your topic. So in today's class we will introduce what is called a system of linear differential equations, and we will see a few basic theorems of system of linear equations which are analogous to the single variable linear differential equations. So like you have seen existence and uniqueness theorem for linear differential equations. In the same way you have seen how are the solutions and the theorems connecting the solutions. So we will see the basic theorems for linear systems in today's class. So in module 1, so we will be looking at the linear systems of 2 equations in 2 unknowns. So first of all we will define what is a linear system of 2 equations in 2 unknowns. So a basic type of system of 2 linear differential equations in 2 unknown is of the form. So the basic type of system of 2 linear differential equations in 2 unknowns will be of the form. So dx by dt equal to a11 of t of t x plus a12 of t y plus f1 of t, and you will have dy by dt equal to a21 of t x plus a22 of t y plus f2 of t. So let us call it as equation 1. So we will using the coming definitions, and here the functions a11, a12, a21, a22, then f1, f2. So they are all continuous functions in a real interval. So a less than or equal to t, less than or equal to b. So this is the definition of a basic type of system of two linear differential equations in two unknowns. So it is of the form dx by dt equal to a11 x plus a12 y plus f1 of t, then dy by dt equal to a21 of x plus a22 of y plus f2 of t. So here the two unknowns are x and y, and you have the two equations here, dx by dt equal to varuna equation, dy by dt equal to varuna equation. So here the functions a11, a12, a21, a22, f1 and f2, they are assumed to be continuous functions over a real interval a less than or equal to t, less than or equal to b. And now the basic type of, this is a basic type of linear system of equations, and this can be classified into homogeneous and non-homogeneous systems. So homogeneous and non-homogeneous linear systems. So we'll look at how do we get a homogeneous and non-homogeneous equation. So if f1 of t and f2 of t are 0 for all t, then we call the system to be a homogeneous linear system. So if f1 of t and f2 of t are 0 for all t, then the linear system is homogeneous, and otherwise it will be called as, so if one of them is not 0, so the system will be non-homogeneous. So in any other case it is non-homogeneous. So that is how we define a homogeneous linear system and a non-homogeneous linear system. So for example, if you take dx by dt equal to 2x plus y and dy by dt equal to 3x plus 5y. So this is an example of a homogeneous system, and if you take dx by dt equal to say 2x plus y plus t and dy by dt equal to 2x plus 3y plus 1. So this is a non-homogeneous system. So those are the two different types of the linear systems. So it can be homogeneous or it can be non-homogeneous. So next we look at ഇനി നമുക്ക് homogeneous system ഉണ്ടെങ്കിൽ our next interest is what is called the solution of a homogeneous system. So we will look at what is defined as the solution of a, so we will look at what is the solution of a linear system. So by solution of a linear system, so that is a pair of functions x and y such that it satisfies the equation. So we will see what is the definition of solution. So we will take the solution in the form x equal to some function of t and y equal to function of t. So you have x equal to f of t and y equal to g of t. So by solution we mean that is an ordered pair fg of real valued functions f and g, which is defined on the interval a less than or equal to t less than or equal to b, such that it satisfies the given linear system. So we will define the solution. So the definition of solution is, so by solution of the linear system we mean, so that is an ordered pair of real functions f of t, g of t, so each having continuous derivatives on a less than or equal to t less than or equal to b, such that, so it must satisfy the given equation. So we must have df by dt equal to a11 of t f of t plus a12 of t g of t plus f1 of t varum, and dg by dt will be equal to a21 of t f of t plus a22 of t g of t plus f2 of t. So for all a less than or equal to t less than or equal to b, or we call the pair f and g to be a solution if it satisfies both the equations simultaneously. From രണ്ട് equation f and g must satisfy both the equations. So this is the meaning of the solution of a linear system. So that's a pair fg which is having continuous derivatives on the interval a less than or equal to t less than or equal to b, such that it satisfies this equation. So x here, x equal to f of t and y equal to g of t must satisfy simultaneously both the equations. So it must satisfy both the equations of the linear system. ഇപ്പോൾ ഏതെങ്കിലും ഒരു equation satisfy ചെയ്താൽ പോരാ, it must satisfy both the equations. So with that we will conclude for today's class. So in the next class we will look at a few more definitions.